Hello, everyone. This is Dr. Jackson, and as promised, I am going to go through and do some of the problems at the end of the chapter for chapter 8. So these are some of those hypothesis testing questions. These are the odd ones, so the answers are there in the back of the book. I figured I'd do a couple of those so that you could kind of see how this works. Also, so you can see how you need to set these problems up when you are working on your assignment. When you go through and you are typing your assignment up, your work should look like this. What you see here where it says step 1, step 2, step 3, step 4, you don't need this table. The table here is for instructional purposes, but you will need the steps. Then you'll need to show your calculations for the computing the test statistic. Then down here, you don't need to put the graph, the normal curve. I have this here again for academic purposes, just to teach you and show you guys some of the things that I'm always saying. You know how I always say you should draw the stuff out on the curve. It'll help you make your decision. But there's some information you're going to need to have down here, and I'll write it in. But what you'll need to do is when you work on this and you putting your hypothesis test together, you'll need to type this information up. Okay, I'm handwriting it so you can actually see me go through and do these calculations. All right, so I'm gonna go ahead and get started. And you know the routine, what I always like to do, which is to highlight the important information and the important information in the problem. So the questions themselves are here in purple. And I also have the number that it corresponds to at the end of the chapter. So at the end of chapter 8. So here we go. Okay, a random sample of 203 social workers. So we know that this is our sample. So that's our sample, our N. So I'm going to go ahead and write that down here. Well, actually, I'm going to wait. I'm going to highlight everything. Then I'll come back and I'll write the information in. So we have a sample. So that would be N of 203 social workers. That sample reports an average annual salary of $25,782. So we know that this is our sample mean, our sample average. And that sample mean has a standard deviation of $622. So what the researchers want to know is this figure significantly higher than the statewide average of $24,509? So that's our population mean. So before I move on, before I start talking about all of this stuff right here, I'm going to go ahead and write these numbers down so that I have that information and I don't have to do it a little bit later. So I'm going to scroll up just a little bit. Okay, give me just a second, you guys. Let's try this one more time. I'm going to scroll up just a little bit. Okay, it's not going to work. That's the best I'm going to get. Okay, so let's go ahead and write these numbers in. All right, I guess we'll stick with the blue we've been using. All right, so the N for this particular problem, the N is going to be 203. Our sample mean, remember I said the problem basically says a random sample of 203 social workers reports an average annual salary. So that lets us know the sample mean, the average salary for the sample is $25,782. And I'm going to come back to the population mean in just a second, but let's go ahead and I'm going to write the information as I see it. The sample standard deviation, because when it says it gives us the average salary with a standard deviation of $622, that's letting us know that is the standard deviation for the sample. So that gives us an S. So our sample standard deviation is $622 or 622. I'm not going to write the dollar signs. All right. And then it says, is this figure significantly higher than the statewide average of $24,509? Because the state, that's our population. All right. So I'm going to come back, but first we're going to go and look at this information here in this table. Let me zoom in so that we can all see this a little better. Okay, so in this table is actually in your book, and it's also in the PowerPoint for chapter 8. I don't remember what slide. I don't remember where exactly it's at in the book. I just know that it's in the book. It may be later on in chapter. Actually, I just found it. It's page 207. So this table that I have on all these problems, it's on page 207 of the course textbook. And maybe use it as a guide um, to help you identify which distribution you need to use. So the first thing that we want to look at, it gives us a couple of things that we need to figure out. So first, we need to determine if the population standard deviation is it known? Okay. So we've already established, by writing all this information out down here, we've already established that the population standard deviation is not known. Okay. All right. So there we go. Let me do this. Okay. Hang on one second, folks. There we go. All right, so we've already established that the population standard deviation is in fact not known. So we know that it's either going to be a T distribution or a Z distribution. It's one of these two. I mean, that information is there already. We know just by looking at the table, it's one of these, but now we have to figure out which one. So the question is this a large sample or is it a small sample? Well, remember, a large sample is anything 100 equal to 100 or greater than or equal to 100. Well, our sample is 203. Okay, so we have 203 social workers. That's well over 100. So we know that our population standard deviation, it's not known, but we're dealing with a large sample. So we're going to have a Z distribution. Okay. All right. So we know that information. Now we can go ahead and start working on each of the different steps. Step one, that's pretty much the one that it's fairly simple. Okay. Just by the nature of what we're doing, we're going to make the assumption that the data is random. It's collected through random sampling. The next thing you need to do is determine, is this interval ratio data or not? And it is. We're able to get a mean. We can do calculations with this data. The only other one we would look at probably is nominal. And if it was nominal, we wouldn't be able to calculate a mean. We wouldn't be able to add or subtract the data itself. Okay. So it's interval ratio. And of course, the stuff it's sampling distribution is normal. When you're writing up the problems, most of this information is going to typically be the same. The one that you have to pay close attention to for step one is interval ratio. Because if you have something that's dealing with proportions, if you're doing a hypothesis test for proportion, it's not going to be interval ratio. Okay. Now, the next step is to state the null hypothesis. And this is where you need to figure out, are you dealing with a one-tailed test or a two-tailed test? And that information is going to be right in the problem. So one of the things that they ask us in the question is, let's see, I think I'll go with green, lime green. Okay, so one of the things that they say in the question, they ask, is this figure significantly higher than the statewide average? So they want to know, this random sample of social workers, is their salary higher than the statewide average? That tells us we've got a direction going on. They want to know, is it higher? So that just by saying higher, that's letting us know that we're dealing with greater than. Okay, so we're dealing with greater than. All right, so and here we go right here. So you can see where it has the greater than sign. So when you're stating the null hypothesis, step two, you state the null hypothesis and you put the research or alternative hypothesis. Remember, the null hypothesis is H sub zero, subscript zero. And the mu, the symbol for mu, which is, the symbol that we use for mean, which is the capital mu sign or something like that. Anyway, the funny looking M is, as I call it, I've just gone and gotten in the habit of writing it as an M, so that you can tell what it is that I'm talking about when I do that. But anyway, remember, you write out that for the null hypothesis, you're basically saying that there are no differences between the two groups, okay? No differences. Whereas the research or alternative hypothesis, you're saying what's basically being predicted in the question. And in this question, they're basically asking, is this figure significantly higher than the statewide average? Well, again, remember that tells us we're dealing with something that's directional. So we're having a one-tailed test, and it's a one-tailed test that we're gonna look at the higher end of the distribution. So we're looking at greater than. So that's how we figure out and determine which sign we need to use. All right, so step 3, this is the part where you need to figure out the sampling distribution. Well, we've done that already. That's what we were doing up here. When I went through and kind of walked through this and figured out this is the one we're going to use, well, that let us know we need this the Z distribution. And for this particular, for what we're working on right now, I believe I set all of these to the alpha of 0.05. Typically, a question is either going to say, it's going to have the information in there, you know, calculate this or do a hypothesis test with alpha equal to 0.05 or alpha equal to 0.01. If it does not state that, if I give you a question and it does not state that, you need to go ahead and use alpha at the 0.05 level. That is the most common alpha that we use in social sciences, particularly in criminal justice and criminological research. We always solve, or we always use alpha at the 0.05 level, okay? So if you ever get a question or you're ever working on a problem or anything like that, and the question itself doesn't say, just go ahead and solve for alpha at the 0.05 level. All right, so, and that's what you need to write here. You say which sampling distribution you're using. You need to put, that's actually the alpha symbol. I don't know how well you can see that, but it's the alpha symbol. So you would put that. If you can't put that, let's say whatever program you're working in, you have a really hard time finding that. You know, there's a way you can find it in Word documents. And if you guys need me to do a real quick video where I demonstrate where to find these symbols in Microsoft Word, just let me know. I can also show you this stuff in PowerPoint as well. So let's say you need to set up your equations and all this stuff in PowerPoint and then cut and paste and turn it over into a Microsoft, or like if you use Google Pages or something like that. Just let me know and I can make a short video showing you where to find these symbols. Okay, so there's that. If you can't find the symbol, you can write out the word alpha. Okay, I'll take the word alpha as well. All right, so then you say what your critical is. Is this going to be a Z critical or T critical? We've already figured out this is a Z distribution, so you're doing Z critical, and you write the corresponding score. For this one, it's going to be 1.65 because we're looking at a one-tailed test. If it was a two-tailed test, it would be 1.96, but we're doing a one-tailed test, okay? All right, so let's go ahead and start working on computing the test statistic. Now, remember I said we don't have the population standard deviation, so we have to calculate the Z obtained using the formula that goes along with the when you don't have the population standard deviation. My apologies. There's so many different terms that sometimes I forget which one I'm trying to say. All right, so as I was saying, Z obtained, and you use the formula that goes with this particular test. So this is the one where it's going to be, here we go. So, you know, I like to write out the formulas. So, I forgot I was still highlighted in highlighter mode. Okay, so it's going to be the sample mean, subtract the population mean, divided by, in this case, because we have the sample standard deviation, we would put the symbol for sample standard deviation divided by the square root of n minus 1. Okay, remember that's That's one of the things, you know, you have to think about and remember which formulas are you using. Okay, so I'm going to come down here. And when I write out Z like this, that's really Z obtained. I just don't want to write out the entire word every single time. So I'm just going to shorten it to Z. That does not mean this is a Z score. This is the Z obtained. Okay. And when you write out the actual answer at the bottom in step 5, I want you to put Z obtained. All right. All right. So Z equals, let's see here. The sample mean is going to be 25,782. Subtract the population mean, which is 24,509. Divide all of that by the sample standard deviation, which in this case is 622, which is divided by the square root of 203 minus 1. All right, let's see how much space I have. I don't have a lot of space. So what I'm going to do normally, and I would suggest you do it this way as well, when you work on these problems, work on them vertically. Vertically. I'll go ahead and write it vertically, but I'm gonna probably have to draw an arrow up to the rest of the information. So mine is gonna go in columns. But the next line will be equal to, now this time, you know, a lot of times I start off here and work my way up. I'm gonna go ahead and do this first so that I don't have to keep writing this long set of numbers out. So let's go ahead and get that calculation clear. All right, so $25,782, because remember this is salaries. These are salaries. Subtract $24,509, and we get 1,273. So equal to 1,273. Then we divide that by 622 divided by the square root. And at this point, I'm just going to go to this, right, to the next step. I'm not going to go ahead and do all those calculations. I want you to see those steps played out. So 203 minus 1 is going to be 202. So the next calculation will be 1,273 divided by 622 divided by, we're going to go ahead and get this square root. So let's go ahead and get the square root. 202. There we go, square root. That's going to be 14 point, and for this set of problems, I am going out to the 4th decimal place. Okay, I'm going out to the 4th decimal place. I think when I tested this out, I think I got the same answer using the 3rd decimal place, but for this, I'm going to go to the 4th decimal place. All right, so then it's going to be 14, let's see, 212, then we have 6 is our 4th number, but that 6 is followed by 7. So it's going to be 14.2127, 14.2127. All right. All right, so let's see. Z is equal to 1,273 divided by, and let's go ahead and do that calculation. All right, so 622 divided by 14.2127. That gives us 43.7636. That 6 is followed by a 7, so that's going to be an 8. Okay, so 43.763, wait, hang on a second. 7636. I went too many numbers. So it's going to be 7636 which is followed by 7. That's going to be 7. So it's going to be 43.7637. All right. This is why it's good to double check. 43.3. No, I don't think that was a 3. I think that was a 7. That's right. Okay, 7. Let's see. It was 7637. 7637. Let's check it one more time. 43.7637. Okay, yes. All right, so looks like I might actually have just barely enough room. All right, so let's see what that z-score ends up being. So now we need to take our number, which is 1,273 divided by 43.7637. That gives us 29.0880. 29.0880, which rounded to the second decimal place becomes Z 29.09. Okay, so I did have enough space. All right, so let's go ahead and so you can see, as you can see, I went vertical with this. This is how I would like for you to set your calculations up when you're doing step number 4, because then if I can see each step instead of trying to figure out things horizontally, I can see each step and see, okay, well, you went from this number, and I can kind of line up your numbers and see where maybe you're having a problem. Okay, so when you're doing the assignment, make sure you set the problems up like that. Then for step number 5, again, remember, you don't have to provide a normal curve table. If you want to, you can, but you don't have to. What you do need is this information right here. You need to tell me your Z critical. Let's try this again. Okay, so you need to tell me the Z critical. Okay, and of course, yours will be typed up so it would look a lot neater. And remember that Z critical, that is this number right here. Okay, so 1.65. And since this is one-tailed, we're not going to have that plus or minus because it's only in one part of the curve. So your Z critical is 1.65. Your Z obtained is going to be equal to 29.09. So let's go ahead and put that on the normal distribution curve. I mean, it's kind of obvious. That's a really big number, but let's go ahead and graph it out, okay? Or draw it out, however you want to put that. Okay, that's supposed to be 1.65. It's not quite halfway, but you get the picture. So 1.65. And remember, everything from on this side, everything going on that falls into this area and beyond, that is our critical region. So we're just going to say that 29 is down here somewhere. Okay, so 29.09. So that definitely falls in our critical region. And for this, I've already typed up the response. I didn't want to make you try to have to read my handwriting when I'm writing on this thing. You know, my handwriting is not the best, but it's not as bad as it is when I'm writing on this. For whatever reason, I have a hard time writing on this. But anyway, here's how you would write the statement out, okay? You could do some variation of this. Use the book, use what I have here, use the information that you see in the PowerPoint, you know, use a number of tools to help you craft the way you want to write these statements. But each of your answers needs to have, your step 5 needs to have the Z critical, and it needs to have Z obtained, and it needs to have this statement, okay? So this is the information that must be in your step 5, all right? Okay, so in this statement, it basically says, there we go, with the Z critical of 1.65 and a Z obtained score of 29.09, the null hypothesis is rejected. So basically, we're saying that the difference between the social worker's average salary and the statewide worker's average salary is statistically significant and in the predicted direction. Social workers had significantly higher salaries than statewide workers. That's what you need to say. That's what I'm looking for, okay? You know, if I were you, I'd probably pause the video at this point, maybe pause it after each one of these that I do. Pause the video and go in and, you know, get this information, write it down so that you know how to mimic it and craft your own statements, okay? All right, so I'm going to go ahead and do the next question, which is question 8.9. So I'll do this one, then I'm going to stop the video and do, I think, the next one, which is 8.11, and that has like two different parts to it. And I'll probably go ahead and get the fourth or fifth, I can't remember how many of them I did, set of questions. So I'm going to try to break this up into 2 videos, because I think at this point I've already been going for about 20 minutes or so. And I know it gets hard to watch these videos when they're super, super long. And I've already given you one extremely long video this week. The part 4, I think it was, of the hypothesis testing, which was like an hour long. So I don't want to have you trying to watch me go through these problems for over an hour. Okay. So having said that, let's go ahead and look at this question. Let's see here. All right, there we go. Okay, so question 8.9, a random sample of, so we've got a sample of 26, a random sample of 26 local sociology graduates scored an average, so the sample scored an average of 458 on the GRE Advanced Sociology test. With a standard deviation of 20, is this significantly different from the national average? And our national average looks to be 4.40. Okay. So let's do a couple of things. First, let's look at this. And we already know that the sample is small. So let's look and see where it says, okay, it doesn't have anything about the sample there. Unknown, and the sample is large. Well, this sample is not large, the sample is small. And there's only one option for a sample that's small. That's the t-distribution. So now what we need to do is, I want to go ahead and do this before I start walking through all of this. I'm going to go ahead and get the t-distribution. And part of the reason why I want to go ahead and get that now is because I have to zoom in on this table. And you know, I don't want to have to work through the problems, zoom in, and then zoom back out. I'd rather go ahead and get that done now. So let me show you on the table, just so I can show you how it's done. All right, so we'll just go to, all right. Oh, actually, let me back up. I just realized something. There is one thing we need to do before we can get to that part, the part that I want to get to with the t-table. So let me back up. Okay, so a couple of things. Remember, this is already, I said that all of these questions, unless it says otherwise, they're set at an alpha level of 0.05. So we know that the alpha is going to be 0.05. You need that information for the t-distribution. The other bit of information that we need to know is this a one-tail or two-tail test? And in looking at this, it just says random sample of sociology graduates scored an average of 458 on the GRE Advanced Sociology test with a standard deviation of 20. All they're asking is this significantly different? It doesn't ask us about anything higher or less. You know, a researcher might decide they want to know, did sociology graduates score significantly higher than everyone else on the GRE? If something like that was in there, then we know it would be a one-tail test. But that information's not there. So I'm treating this like a two-tail test, okay? So that's important. The alpha level and the type of test that's being done, you need that information for the t-distribution. Okay, so let's go ahead and take a look. So the first thing, remember our sample, okay, you can't see it here, but our sample is 26 people. Yeah, we have a random sample of 26. Okay, so that's important because that's how we get our degrees of freedom. That's how we know what number to look at over here. And on this particular table, they have a thing there so you can see what the calculation is. The table in the back of the book does not have that, but just remember, take the number that's in your sample, subtracted by 1, you get your degrees of freedom, okay? So let's go ahead and go here. You can do this in whatever order you want. You can do this in whatever order you want. If you want, you can start up here. And remember, I said that this is a two-tailed test. So for this one, we would look at this part of the table. Okay, so you look here at the top. Is it two-tailed or is it one-tailed? We said it's two-tailed, and we are looking for something with an alpha level of 0.05. So right here. And so what I'm going to do is just kind of color it in like this. Okay. Just going to do it like that. Okay, so we're already at 26. And then you find, not 26, you find your degrees of freedom, that column right here. Now, what I need to do first, before I can get the number, I need to take 26 minus 1. It's going to give us 25. So right here. All right, but it's easier for me to just go through, highlight across, find out where the numbers intersect. Okay, so those numbers intersect at 2060. 2060. All right, so let's go ahead and go back over to where we need to be in the problem. Okay, first I need to zoom back out. Okay, let's see if we can get, there we go. Move this over, there's the cursor. That's what I'm looking for. Okay. Yes, I think out loud when I'm working on problems. When I'm working on math problems, I tend to solve them out loud and think out loud. Don't judge me. Okay, so now to get down to the nitty-gritty of it, let's go ahead and start writing the information out. I've already highlighted the important parts of the problem. So we know we have a sample of 26, so that means our number, our n, so I'm down here at the bottom at step O. I want to go ahead and write this stuff out, and then I'll go through each of the steps. So my n is equal to 26. Because remember, I have a random sample of 26 sociology students. Then their grad date, this particular group, their GRE score, so the sample mean is going to be equal to 458. The next thing that we're given is the standard deviation. The sample standard deviation and the population average, the national average. The national average is 440. The standard deviation is 20. So 440 and then 20. Okay, so we'll take care of all of that when it comes time to do the test. All right, as I've said before, this first part, step 1, that's pretty straightforward, okay? That is random sampling. Some of those, these are those assumptions that we're going to make. I talked about them on the previous problem, so I'm not going to talk about them all that much here, other than to say you need to make sure you have them. Make sure you have them there. Now, step 2, stating the null hypothesis. Remember, this is a two-tailed test, so you don't need to worry about which way the arrow goes. You are not going in one direction. This is a two-tailed test, so it's going to be on both sides of the distribution, right? Yes, it's going to be on both sides of the distribution, or we're looking at both sides of the distribution. We just want to know, is there a difference? We're not worried about, is it higher, is it lower? We just want to know, is there a difference between these two groups? And that's how you write this out. So basically the research hypothesis, the research hypothesis, which is this one right here, the H subscript 1, that's our research hypothesis. We're basically saying, no, these two are not the same. The sample is not the same as the population mean. This sample, there's something different about this sample. Now, selecting the sampling distribution, we've already figured that out. All you have to do at this point is plug in the information. We figured out up here that we're dealing with a T distribution, so that's what you need to input here. I already said that the alpha for, I'm pretty sure all of these practice problems is going to be set at the 0.05 level. And we already found the T critical score. That's what we did over here in this chart, where I have the green highlight and I showed you where the intersection is. You remember that number was 2 0.060, okay? And that's because this T critical was a two-tailed test. So now we can go ahead and compute the test statistic, okay? All right, so this is a T distribution. So we're going to do, we're solving for T obtained. Again, just like with the Z obtained, I'm not gonna write out that whole word, but when you do your problems, when you get to step 5, you need to write out T obtained. For the calculation, you don't have to write out T obtained, you can just write T. Yeah, you can just write out T, but remember, this is not a Z score, it's not a T score, okay? This is T obtained. This is your test statistic. All right, so the formula for that is sample mean minus the population mean divided by the sample standard deviation, which is then divided by n minus 1, okay? I did that as a lowercase n, that's fine. Your book has it as a capital N, that's fine. You guys aren't dealing with stuff where you have to have the different numbers for the populations and the samples. I just wrote a lowercase n because that's just what I wrote. All right, so let's go ahead. Let me go ahead and put T. If at any point I start writing a Z, just don't panic. It may mean that I'm so used to just dealing with and doing problems for Z and these formulas look the same that I may have just switched over in my brain to Z, but it's really T for this particular problem. Okay, so the T, let's go ahead and plug these numbers in. So we've got 458, subtract the mean, which is 440, which is then going to be divided by the sample standard deviation, which is 20, divided by the number, the square root of the number minus 1, which is 26 minus 1. All right, so let's go ahead and come here. So let's go ahead and calculate this top row. Uh-oh, that is not what you guys need to see. I was checking something. Actually, I was checking a number for you guys, something that was rounding. I was making sure it rounded the way it's supposed to. So you got to see behind the scenes a little bit. Okay, so 458, subtract 440. That gives us 18. Okay, so 18 divided by 20, which is then divided by the square root of 25. Okay. Now let's come down here again, 18 divided by 20. Now let's go ahead and get that square root. Yes, it is just that simple. This one is that simple. So 26 minus the 1 is 25. Square root of 25 is 5. Okay, so that should be pretty straightforward. All right, now let's scroll down a little bit so we can keep going. All right, T is equal to 18 divided by, I'm gonna go ahead and do the calculation. Oh, I got rid of my calculator. Give me just a second, folks. Let me go get my calculator back. Okay, we're gonna put this over here and then I'll size it down in a minute. Okay, so what did I say? 20 divided by 5. You should know, hopefully you know that's 4. Excuse me. I think I did the wrong thing. 20, yeah, no, I had it backwards. 20 divided by 5 is 4. Okay, there we go. So let's see here. 20 divided by 5 is going to be 4. So our T obtained should be, let's go ahead and get this back. 18 divided by 4, which gives us 4.5. Okay. Now, because I like to see 2 decimal places, go ahead and put a 0, but our T obtained is equal to 4.5. All right. So, and if you want to go back and you want to check in the back of your book, this is question 8.9. And for all of the odd problems that are in the book, yeah, for all of the odd problems that are at the end of your chapter, it has the answers for those. And this is 8.9, okay? I actually went and checked myself just because when I did it, I said, these numbers can't be that easy. They just can't be. But it just worked out that way. All right, so, okay, the reason I'm scrolling back up. So our T critical, because now we're at the point where we're going to write the information in for step 5. Our T critical for step 5 is going to be plus or minus 2.060. So let's go ahead and write that. All right, so T critical is going to be equal to plus or minus 2.060. Let me double check. I just want to be certain. Yes. And our T obtained is equal to 4.50. Now let's go ahead and do this over here on the distribution. Now, the thing is, if this were an actual T distribution, I just got a curve. This represents the normal curve. The T distribution does not necessarily look like this. Remember, the T distribution is flatter. I just wanted something so that I would be able to graph these out. This is more of a visual for me so that I can make sure things are correct. Even though looking at this, I know that this number is going to be beyond the it's going to be in the critical region. Okay, so our T critical is at right around 2, so plus or minus 2. Okay, so 2.060, 2.060. And our T obtained is going to be 4.50, which is going to be out here somewhere. And because it's not plus or minus, your T obtained is just the number. We know that it's on this side and it is beyond, because remember, anything beyond this number here, everything that goes all this way, that's your critical region, okay? And the 4.50 falls in the critical region. So we're gonna go ahead and interpret that. With the T, this is how you would write it or how you would interpret it. Remember, this is a two-tailed test, so it's going to look a little bit different than the previous interpretation. So this one, it's with a T critical of plus or minus 2.060 and a T obtained score of 4.5, the null hypothesis is rejected. The difference between the GRE scores of sociology graduates and the national GRE scores is statistically significant. That should say GRE scores nationwide. Okay. Okay, national average. Okay, so I guess I put it correctly. I think maybe I should have national average in there. So let me go ahead and type that in there, just so you can see that and you can see how it should look. I think I was moving too fast. And the national average GRE scores. Okay, so yes, here we go. So let me start that over again. With the T critical of plus or minus 2.060 and the T obtained score of 4.5, the null hypothesis is rejected. The difference between the GRE scores of sociology graduates and the national GRE scores is statistically significant. The difference is so large that we may conclude it did not occur by random chance. The decision to reject the null hypothesis has a 0.05 probability of being wrong. You could have some of the same information in that previous interpretation, the one for the one-tailed. I just didn't include it in there. But you could say the decision to reject the null hypothesis has a 0.05 probability of being wrong. These differences that we found didn't occur by chance. You can make some combination of these two statements, just as long as you make sure you can demonstrate that, if it's a one-tailed test, you indicate the direction of the difference. If it's a two-tailed test, you just say, hey, there's a difference between these two. It's not by random chance. We reject the null. There are key things that you need to have in these interpretations. Okay, so at this point, I'm going to go ahead and stop. and get started on part 2 of this demonstration of these problems. So the next problem that I will do is, looks like I need to fix a few things too. The next problem that I will do is question 8.11, okay, 8.11.